Hello everyone. Today we are going to start lecture 06 of class 8 mathematics chapter number 9, which is algebraic expressions and identities. Now in this lecture we are going to talk about identities. What are algebraic identities and how they are useful to us while we are solving some algebraic expressions and we are simplifying them, right? Also, we will learn to evaluate some numerical values with the help of these identities. So first of all, let us talk about what is an identity. Now you all know that an equation is something which is an equal sign. So an algebraic equation contains some constants and variables, but an equation is true only for some certain values of x. And we have also solved them in linear equations, right? But when there is a particular equation which is true for all the values of variables, then it is not an equation anymore. It is called an identity. Okay, let me give you an example. Let us take 2x plus 4 is equals to 8. Okay, now do you think that this is an equation? Yes, this is an equation because it is an equal sign. Now do you think it is an identity? Let us solve. We'll see that 2x equals to 8 minus 4, which is 4. So x is equals to 2. Okay, so 2x plus 4 is equals to 8 is true only for x is equals to 2. So you can clearly see that this is an equation and it is true only for x equals to 2. If you try to put x equals to 3, you will not get 8. Okay, so it will not be true for any other value of x. So these are equations. So what are identities? Identities are something which are actually true for all the variables. Okay, so if I have to write the definition for identity, then I can write an identity. An identity is an equality, that is, it is also an equation. An identity is an equality which is true. An identity is an equality which is true for all values of the variables, right? So you can clearly see that this, so here 2x plus 4 is equals to 8 is not an identity, right? You can clearly say that this is not true for all values of x, so it is not an identity. So what is an example of identity? Okay, if you want to take an example of identity, then see x plus 2x is equals to 3x. Now you will say, sir, it is very easy. You are just adding them. How you are calling it an identity? I will say because for no matter what is x, even if you change the variable, if you make it y plus 2y will also be 3y. You will say yes, because it is obvious. Okay, it is the next 3x is the next step while adding the x plus 2x. Okay, when you are adding x plus 2x, the next step would be 3x only. So it is quite obvious. So these type of equations which are actually true for all variables, for all values of a particular variable, then they are called identities. Now in this case, 2x plus 4 equals to, it is a specific equation. It is representing some condition and it is true only for that condition. So here it is true for x equals to 2. It might be another x for any other condition, but it will not be true for all the values of variables. We have to find an equation which is true for all the variables, which is this, that is x plus 2x equals to 3x. Similarly, you can also take x into, let's say, 4x is equals to 4 of x square. That is also an identity. This equation is also identity because even if you put a into 4, it would also be 4a square. Even if you put any numerical value in x, then also it will be true. So you know that it is an identity. Okay, so if these are identity, then you can say that we can make innumerable identities. Okay, what is the use of studying them? See, there are some specific identities which actually make a calculation, or specifically talking algebraic multiplication, very easy. Okay, so there are some 4 basic identities which we have to talk. Okay, so let us move on to them. Now we have understood the difference between a simple equation and an identity. Identity is also an equation. Okay, but it is an equation which is true for all values of variables. So we can write one more thing which will conclude us all this thing. All identities are equations but all equations are not identities, right? So you can see that all the equations are not identities, but all identities itself are equations because they contain an equal sign. Okay, let us move on to the first identity, which is very famous. You must have studied them previously also, but from now onwards and for the future classes also, this identity and the identities which I'm going to tell you will be used extensively. This is a plus b whole square equals to a square plus 2ab plus b square. You should always learn this in this order only. So that is the first identity. Let me show you how we achieve this. So a plus b whole square is equals to a plus b into a plus b. Okay, now it is product of binomials. We have already seen it, so it will be like this. Using the distributive property, it will be like this. Finally we will have a square plus ab plus, again b into a would be ab plus b square. Adding them we will get a square plus 2ab plus b square. Okay, so that is how you can prove this identity, which is a plus b whole square. So this was the first identity, which actually talks about multiplication of the same binomials. Okay, let us move on to the next identity, which is a minus b whole square. Now that is again the same, talks about product of binomials, but here the binomials are getting subtracted from each other. Okay, see a minus b and it is also a minus b. Next factor will also be a minus b. So we have to multiply binomial with binomial, but now those binomial have negative sign in between. Okay, so let us prove that. So a minus b whole square is equals to what? A minus b into a minus b, again product of binomials. Using the distributive property we will have like this. Okay, so it will be a square minus ab. It will again be minus ab plus b square. Okay, minus into minus plus, so it will be a square. These are like terms, so they can be added like this, and this will be b square. Okay, so this was the second identity. It is nothing but it is the just the additive. We are just adding the additive inverse of b. Okay, in this also you can learn this identity by, see, a minus b whole square is nothing, it is a plus of minus b whole square. Okay, so that is what, so you can open it for positive square also. A square plus 2 into a into minus b plus minus b whole square. Okay, because we are writing now a plus b whole square, so a plus b whole square is this. Now minus b is acting like b only. Okay, so when you open it, it will be, minus will come outside, so minus 2ab, and minus b square is also plus b square. Okay, so even if you know a plus b whole square, just replace b with minus b. Okay, and you will get this a minus b whole square. Okay, so it is very easy. You should always know about this additive inverse technique. It is very easy because in future classes it will help you to learn a minus b whole cube and all those identities, right? Okay, let us move on to the third identity, which is a plus b into a minus b. Okay, this is a square minus b square. Now this is also very extensively used. Okay, this identity is very much used whenever you have to calculate numerical values. Okay, so let us prove that also. Now it is already given in the form of product of binomials, so let us just multiply them. So here it will be a into a minus b into a minus b, right? It will be a square minus ab. Okay, and minus ab, and it will be minus ab plus b square. Okay, it was a plus b into a minus b, like this. So a plus b into a minus b, yes, it is correct. So a plus b into a minus b, right? So now we'll distribute it. So a square, it will be plus ab, it will be minus ab, and it will be minus of b square, right? So it will be minus of b square. Now you can clearly see that after distributing a plus b over this a minus b, what we got, a square plus ab minus ab. Now plus ab minus ab will get cancelled and you will get a square minus b square. You could also distribute a minus b towards them. Then also you will get the same answer, a square minus b square. So this was the third identity, right? Let us move on to the next identity. Okay. This identity is x plus a into x plus b is equals to x square plus a plus b of x plus ab. Now this identity is useful when you have some this kinds of binomial, right? X plus something and an x plus another thing. Okay, so variable is same, power is same, and just these a and b are different, then you can directly add them. Okay, so if we have to prove it or you have to verify it, then it will be x plus a into x plus b. Distributing this, it will be x plus b plus a into x plus b. Multiplying them, it would be x square plus bx plus ax plus b. Now we have got the product, so we will just, it will be ab. So we will just take x common from them, so it will be a plus b, and we have taken x common, and finally we will get a plus b. Okay, so this identity is very much useful whenever we are talking about numerical values. Okay, so let us solve some questions so that we can further strengthen the use of these identities, and I will make you recall identity in every question so that by the end of this lecture you will be able to learn all these 4 identities, and you should learn them well because they will be used in the future chapters also. So let us move on to the questions. So we have to evaluate 2x plus 3y whole square. Now it is 2x plus 3y into 2x plus 3y. I can write it as a product of binomials, but just to make it short, we will use identity. Okay, that is why we are using identities to make this product short. Okay, so 2x plus 3y whole square. Now let us compare to ax plus by whole square, right? It will be a square plus 2 into a into b plus b square. So what is the identity I have used here? Since a plus b whole square is equals to a square plus 2ab plus b square, and here you can see a is 2x. 2x is performing the duty of a and 3y is performing the duty of b. So you can clearly see a plus b whole square would be like this. So the final answer would be 2x square, that is 4x square. 2 into 2, 4 into 3, it will be 12, x into y, xy, plus 3y square, that is 9y square. So you can clearly see it will be 4x square plus 2xy plus 9y square. Okay, so that is the use of a plus b whole square. Let us say the use of a minus b whole square. Okay, it is the same question, we have just put a minus over here. Okay, so let us solve it. Now 2x minus 3y whole square would be a square minus, because there is minus, 2a into b plus b square. Okay, if you want to know what identity we have used, how we have used it, so we can write, since a minus b whole square is equals to a square minus 2ab plus b square. Here a is equals to 2x and b is equals to 3y. So we are taking a as 2x and b as 3y. So it will be 2x whole square, that is 4 of x square, minus 2 into 2, 4 into 3, 12. So 12xy plus 9y square. Okay, so it will be 2x minus 3y whole square. Now let us see the use of the third identity, that is a plus b into a minus b. So we have a plus b into a minus b. See, what we can do is we can arrange it like this. You have two options. Now if you do not want to use identity, you have to multiply them element wise. It will take more time. You will see that how identity will make it easier. So according to the identity, it will be 2x whole square minus 3y whole square. How? Let me show you with the help of identity that how we are writing all this. Since a plus b into a minus b has been given as a square minus b square, and here what we are doing, here we are taking a as 2x and b as 3y. So it will be a plus b into a minus b, a square minus b square, which is 4x square minus 9 y square. 3y whole square will be 3 square into y square. So you can clearly check the answer. It would be 4x square minus 9y square. So in these questions, first of all, we have talked about a plus b whole square. You will see that in the answer there is plus 2xy. Here the only difference is minus 12xy, and here the term xy would be cancelled out. Okay, and it would be a square minus b square. So I hope you must be getting what is the use of these identities and how to apply them. Okay, let us move on to the next question. It says find the product of the following binomials. Okay, so the given binomials are these two binomials and we have to find their product. So it is 2 upon 3 x square plus 5 y square into 2 upon 3 x square plus 5 y square. Right. So in this way we have to multiply. Now you can see these are the same products, so you can write it. You can write it as 2 upon 3 x square plus 5y square whole square. Okay, it is just nothing but the whole square, and if you want to open it, it will be like a plus b whole square. So it will be a square plus 2ab, that is 2 upon 3 plus b square, that is 5y square whole square. Right. Now if you wish to write the identity, it is a plus b whole square is equals to a square plus 2ab plus b square. Okay, and here a is equals to 2 upon 3 x square and b is equals to 5y square. Right. So here a is equals to 2 upon 3 x square and b is equals to 5y square. So after opening we will get 2 upon 3 square would be what? 4 upon 9, and x square whole square would be x raised to the power 4. Okay, you can also write here, since a raised to the power m raised to the whole power n is equals to a raised to the power m into n. So the power to the power get multiplied. So 2 into 2 would be 4. Similarly here it is 2 into 2 4, 4 into 5. So it would be 20 upon 3 x square y square plus it would be 5 square, that is 25 y raised to the power 4. So it will be 4 by 9 x raised to the power 4 plus 20 by 3 x square y square plus 20 y raised to the power 4. Okay, so that is the product. Let us move on to the next question. Now this question says find the product of the following binomials. Now here also you can clearly see this is 6x square minus 7y square, and this is also same. So it is just the whole square. Okay, but it will be a minus b whole square this time. So let us solve it. 6x square minus 7y square into 6x square minus 7y square. Okay, so it would be what? If you actually open it, it will be 6x square minus 7y square whole square, right, which would be a square minus 2ab plus b square. Okay, if you want to know the identity how we did it, so we can write a minus b whole square is equals to a square minus 2ab plus b square, right? And what have we taken a and b? So a would be this 6x square and b would be this 7y square. So it would be 6 square would be 36, x square whole square would be x raised to the power 4 minus 2 into 6 12, 12 into 7 would be 84. So 84 x square y square plus 7 square would be 49 y raised to the power 4. Okay, so you can clearly see this is the final answer. So we have used a minus b whole square to solve this particular question. Let us move on to the next question. Now this question says that find the product. So again you can clearly see this is a plus b into a minus b. Okay, 3 by 4x and 3 by 4x same. So let us take it a, and 5 by 6 let us take it b. So it is a plus b into a minus b. So 3 upon 4x plus 5 upon 6y into 3 upon 4x minus 5 upon 6y. Okay, so it would be what? It would be a square minus b square, right? 3 by 4x whole square minus 5 by 6y whole square. Okay, how? So if you want to write the identity, we can write since a plus b into a minus b is equals to a square minus b square. And what have you taken a and b? A has been taken as 3 upon 4x and b has been taken as 5 upon 6y. Okay, so it would be a plus b into a minus b, that is a square minus b square. A and b are given, so it would be 3 upon 4 whole square, that is 9 whole upon 16 x square minus 5 square 25, 6 square 36, so it would be 25 upon 36 y square. Okay, so that would be the final answer. So we have multiplied them 3 upon 4x plus 5 upon 6y into 3 upon 4x minus 5 upon 6y. So you can cross check if you want to do it. Okay, so it will be 9 by 16 x square minus 25 by 36 x square. Let us move on to the next question. Okay, so the next question is 2a plus 3 upon b into 2a minus 3 upon b. Again the same question, a minus b, a plus b into a minus b. Okay, so that is what we have to calculate. Now again let us try it. So 2a plus 3 upon b into 2a minus 3 upon b. Okay, so it will be 2a square minus 3 upon b whole square. Now again if you want to write identity you can do that, but let us now write it without the identity because we have just used it. So here a will be this 2a and b will be this b. So it will be 4 of a square minus 9 of b square. See, in 2 steps you can calculate the answer, otherwise you have to multiply them element wise, then you have to see the like terms, you have to add and subtract, and then you will get to this answer. Okay, so that is the use of these identity. Let us move on to the next question. Now this question says that if x plus y is equals to 12 and x into y is 14, find the value of x square plus y square. So obviously it is talking about plus, so let us talk about a plus b whole square. Okay, so we are given a x plus y and x square plus y square we have to find, and x y is given. So you can use we know that x plus y whole square is equals to x square plus 2xy plus y square, right? So I got an idea from this and this. Now you can see you can put the values. X plus y is equals to 12, so 12 square is equals to, here you can put them together, x square plus y square plus 2xy. So 12 square is equals to 144, and x square plus y square has been given. Sorry, we have to find it. So x square plus y square has been, we have to find it, plus now 2xy, xy has been 14, so it will be 2 into 14. Okay, so what would be x square plus y square? X square plus y square would be this 144, and this 14 into 28 would go on the left hand side and it would become negative. So x square plus y square would come out to be 144 minus 28, which will be 124 minus 8, that is 116. Okay, so we have applied a plus b whole square just to calculate this question. I hope you all got it. It was very easy. Let us move on to the next question. It says find the continued product x plus 2 into x minus 2 into x square plus 4. Okay, so with the help of this binomial multiplication it will be very long, but see, with the help of identities it become very easy. X plus 2 into x minus 2 into x square plus 4. It will be x plus 2 into x minus 2 would be x square minus 4. Okay, so we are multiplying these two together. Now how have we done it? Let me write the relevant identity. So a plus b into a minus b, that is what we have used. A plus b into a minus b, that is a square minus b square. Okay, now again the same identity would be used here. It would be x square whole square minus 4 whole square. Okay, same identity, a plus b into a minus b, and it would be x raised to the power 4 minus 4 square would be 16. Okay, you can clearly see we have applied these identities twice. In the first case a was x, b was 2. In the second case a was x square and b was 4. Let us move on to the next question. Now you can very well imagine that if you had multiplied with binomial multiplication, first of all you have to do that, then you have to multiply with them. They would contain a lot of terms and you have to cancel most of them, right? They would cancel out because the final answer is this, x raised to the power 4 minus 16. So you can very well imagine that without identities it would be very tedious process to calculate the final answer. Okay, now the next question is again the same. It says that find the continued product. So let us see what identities can we apply here. 2x minus 3y into 4x square plus 9y square. Now obviously multiplying these two together, it is a plus b into a minus b, so it will be a square minus b square, and it would be 4x square plus 9y square. Okay, so what is the identity we have used here? It would be a plus b into a minus b, that is a square minus b square. Okay, so it would be 2x whole square, that is 4x square minus 3y whole square, that is 9y square. It will be 4x square plus 9y square. So again we can multiply, we can use a plus b into a minus b. See, 4x square would be a, 9y square would act as b. So it will be a square minus what you have assumed b, 9y square, b square. So you should be very careful while assuming them. Otherwise writing them and solving them is quite easy. So 4 square would be 16, it would be x raised to the power 4 minus 9 square would be 81, it would be y raised to the power 4. Okay, so you can clearly see that the first product in the case was also a binomial and it also turned out to be a binomial. But had you multiplied it using the binomial multiplication, it would be very long and tedious process. Okay, so let us move on to the next question. Now see, I told you that we have some numerical applications also. Now to calculate these type of numbers, these identities which we have studied would be very useful. So let us talk about first 101 square. Now with actual multiplication it would be very hard, but I can write it as 100 plus 1 whole square. So now it has become a plus b whole square. So it is a square plus 2 into a into b plus b square. Okay, so you can assume that a is equals to 100 and b is equals to 1. So you have used the identity. So let me write the identity. Since a plus b whole square is equals to a square plus 2ab plus b square, right? So you can clearly see that now after opening the square it will be 10,000 plus it would be 200 plus 1. So it is 10,000 and 201. So it would be 10,201. So you can clearly see it was very easy to add them actually. Had you gone for the multiplication, actual multiplication 101 into 101, it would be very lengthy. Okay, so you can see we have found the answer, and see the chances of committing mistakes are also very less. Let us solve the second part, which is 99 square. So again you can very well imagine what I will do now. See, 99 square is also tedious to calculate, so I will write it like this, 100 minus 1, because calculating squares of 100, multiples of 100 is very easy. So I am going to use a minus b whole square. So I can write a minus b whole square equals to a square minus 2ab plus b square. Okay, so it would be a square, that is 100 square minus twice of ab plus b square. So it would be 10,000 minus 200 plus 1. So it would be 9800 plus 1, that is 9801. Okay, so you can very well see that it is very easy to calculate these types of square using these identities. Let us move on to the next question. Now it says that using this identity, now the question itself is giving the identity, it is asking to solve these questions using this identity. So it is very easy. Now 68 into 72, let us solve the first part. 68 into 72 can be written as, see, it can be written as 70 minus 2, because see, it is a plus b, a minus b, so same number plus same number, so 70 plus 2. We can write 72 as 70 plus 2 and 68 as 70 minus 2. So a plus b, a minus b, right? 68 can be written like this and 72 can be written 70 plus 2. So it will be a plus b into a minus b, which will be a square minus b square. Identify a would be 70, b is equals to 2. 70 square would be 749 and then 10. 4900 minus it would be 16. Okay, so it would be what? 4. Okay, it is not 4, it is 2. So 2 square, that is 4, so it will be 4 8 9 6, right? So a square minus b square, that is 4900 minus 2, so it would be 4896. Let us move on to the second part and see how can we solve second part using this identity. Again, we have to write it like that only. Now 101 into 99 would be 100 plus 1 into 100 minus 1. So it can be written as a plus b into a minus b. Okay, so it will be a square minus b square. We have used the identity. Identify a and b over here. So a is equals to 100 and b is equals to 1. See, in the previous question also I have written 4, but I corrected it to 2 because I have identified them. So these are also the cross check parameters which will not allow you to commit mistakes. So you should never avoid to write them. Okay, it will take hardly 2 to 3 seconds, but they will save you a complete question. So it will be 10,000 minus 1. So we all know that it would be 9999. This is the largest 4-digit number, right? And this 10,000 is what? It is the smallest 5-digit number. So there is a difference of 1 only. Okay, let us move on to the next question. Now these are based on the identity number 4. Okay, so let us find x plus a into x plus b. Okay, so this x plus 2 into x plus 3. So let us solve the first part. X plus 2 into x plus 3, that is x plus a into x plus b, would be x square plus a plus bx, that is 2 plus 3 of x plus ab, that is 2 into 3. Now how have you done it? Let me show you the identity. Since x plus a into x plus b is equals to x square plus a plus b of x plus of ab, and here x is equals to x only. Okay, but a is equals to 2 and b is equals to 3. Okay, so the final answer would be x square plus 2 plus 3, that is 5x, and 2 into 3 would be 6. So you can multiply, you can go through the binomial product also, but you will take a long time, and with the identity you can easily solve it. So this was the use of this identity. Let us solve the second part, which is again based on the same identity, but here the values of a and b are different. Now x plus 7 into x minus 2. So you can write it like x plus 7 into x plus of minus 2, right? So it would be x square plus a plus bx. So a plus b, that is 7 plus of minus 2 into x plus ab, that is 7 into minus 2. So here I can tell you that here I have taken a is equals to 7 and b is equals to minus 2. We have applied the same identity, x square plus a plus bx. So it would be x square plus 7 minus 2 of x, and here it would be minus 14. So the final answer would be x square plus 5x minus 14. And if you multiply through binomial product also, that is doing the product element wise, then also it will be the same answer. So you should be careful while taking the signs, and you should always try to use this small bracket so that they will not allow you to commit mistakes. Let us move on to the third part, which is 3x plus 4 into 3x minus 5. So it is 3x plus 4 into 3x minus 5. Right. Now if you want to calculate them, then again it is we can use the identity x plus a to x plus b, but now the duty of x is denoted played by 3x. Okay, so it would be x square, that is 3x square, plus a plus b of x, that is 4 minus 5. Okay, 4 plus of minus 5 you can write like that also. Let us write like that only. A plus b of x plus ab, that is 4 into minus 5. And what is x? 3x. Okay, so that is how you will arrange it. Now if I have to write the identity, what I will write is, since x plus a into x plus b is equals to x square plus a plus b x plus ab. Now let me write what are the roles of a, b and x over here. Here in this question, x has been 3x, so I have used 3x square, and here also I have used 3x. Similarly, a has been 4, so wherever there is a I have kept 4, and b we have taken as minus 5. Right, so I have put minus 5. I have replaced b by minus 5 in this identity. So final answer would be 3x whole square, that is 9x square. Now it would be 4 minus 5. 4 minus 5 of 3x, it would be minus 20. So the final answer would be 9x square minus 1 into 3x, that is minus 3x minus 20. Okay, so that would be the final answer, 9x square minus 3x minus 20. Now let us solve some numerical questions on the basis of this identity. So in this part it is 107 into 103. Now if you multiply it conventionally, it would take a lot of time because it is a 3-digit multiplication. But see, here I can write it like this: 100 plus 7 into 100 plus 3. Okay, this number, this first term should be same. Okay, that is the requirement in the identity. So it would be what? X square plus a plus bx, that is 7 plus 3 into x plus ab. Okay, so here I will write that a is equals to 7, b is equals to 3, and x is equals to 100. Now 100 square would be 10,000 plus 7 plus 3 would be 10, and 10 into 100 would be 1000 plus 7 into 3 would be 21. So it would be 10,000 plus 1000 plus 21, that is 11,021. Okay, so it was that easy to calculate the product using this identity. Let us move on to the second part. It is 56 into 48. Okay, so 56 into 48. Now I have to write it carefully using the same first term. So see, they can be written in the terms of 50. I can write it as 50 plus 6, and I can write as 50 minus 2. See, you can write it as 60 minus 4 also. But see, 60 minus 4 and 50 plus 50 minus 2 will not make any identity. Here at least x should be same. A and b can be different. It can be positive, it can be negative. So it will be x square plus a plus bx, that is 6 minus 2 of x. X is 50. Plus AB. Okay, so you can write here x equals to 50, a is equals to 6, and b is equals to minus 2. So it will be 50 square, that is 2500, and it will be 4 into 50, that is 200, and it would be minus 12, that is 2700 minus 12. Okay, so it would be 2688. So you can clearly see how fast we have calculated the product using the identities. So in this lecture we have talked about the identities. There were 4 identities. So they were a plus b whole square, a minus b whole square, a plus b into a minus b, and x plus a into x plus b. You should learn them both ways, right? If you have been given a square minus 2ab plus b square, so you should be able to recognize it, and you can write it in the form of a plus b whole square. These type of questions are also very prevalent. Okay, so this was all about this lecture. Thank you for watching this lecture till end. I hope that you got my point and you will learn these identities. Okay, we'll meet in the next lecture. Till then, goodbye.